Hello, and welcome to Newton's Laws of Motion Experiment Lab. We will be demonstrating many different experiments that will show the different laws of motion.
I'm Bubby Joe.
I'm Paige.
I'm Abby.
I'm Ashley.
And Faye. I'm Brooke. And today is October 3rd, and we are in Block 4.
Newton's first law of motion states that any object in motion will stay in motion and any object at rest will stay at rest until the objects are acted upon by an outside force.
This experiment will show Newton's first law of motion. Newton's first law of motion is demonstrated in this project because the cups are staying at rest until the force of pulling the paper is being acted upon the cups. The cups are moving until they are stopped by the cup below. Gravity is pulling the cups down. This is another example of Newton's first law of motion. The coin has inertia, meaning it really wants to stay in one place. If you move the cup slowly, it isn't fast enough to overcome that force. If you flick it quickly, the coin stays in one place and then drops into the cup due to gravity. An object at rest will remain at rest.
Newton's second law of motion states that the force of an object is equal to its mass times its acceleration. Other properties include a change in motion occurs only if a net force is exerted on an object. A net force changes the velocity of the object and that causes it to accelerate. The acceleration of the object is dependent on its mass. The more mass that there is, there's less acceleration.
For the experiment that we had already done, the demonstration showed when we used a tennis ball and a smaller, denser black ball that the black ball knocked over the textbook because it had a greater mass than the tennis ball, therefore a greater acceleration. And when thrown with the same force, the black ball with a greater amount of force. As you saw in the demonstration, the tennis ball was able to knock over the dominoes, but the paper ball couldn't. The tennis ball has a greater mass than the paper ball, which meant if you threw them with the same amount of force, the tennis ball would be able to knock the dominoes over because it has more mass and also a greater acceleration.
Newton's third law states that for every action there is an equal and opposite reaction. Other properties include when an object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first object. The force exerted by the first object is the action force. The force exerted by the second object is the reaction force.
Yeah.
When the air pressure is released from the balloon, it causes an opposite equal reaction. This then pushes the balloon up the string because the outside air is the opposing force and the outside air pushes it back. As a result, the balloon is pushed forward. This is also how rockets work. When you throw the tennis ball against the ground, the ball bounces up in an equal and opposite force. The floor has a greater mass than the ball, which propels the ball upward in the opposite direction. The harder you throw the ball, the harder it will hit the ground and the higher it will bounce up.
Oh, that was such